Okay, hello AP Physics people. It's Mr. Martineau again, Marty, whatever name you want to call me. That's presentable. What we're going to do here is this is our second video for Concave Mirror. So if you didn't watch the first video, make sure you watch the first video because there's some setup here that I'm skipping for this one because you should know how to do it. Once again, we have our concave mirror. It's mirrored on this side. Once again, we're establishing our coordinate system, positive over here, negative over here. I'm not going to re-explain because you're supposed to have watched the first video. Now what we're going to have is our same center of curvature. We're going to still say the center of curvature is 10, focal point is 5. Now what we're going to do is we're going to place our object at the focal point. Okay, so if we come back over here, I have put an arrow, which is our object, on the focal point. So F and DO are the same distance away from the mirror, which again we are calling x equals 0. Again, just as a reminder, I'm trying to stay consistent. The height of the object will again be 3 centimeters. Okay, and now what we want to see is what images are going to be created when I put the object at the focal point. In the last video, the object was beyond the center of curvature. Now we're going to be on the focal point. Same rules are going to apply. We're still going to have 3 rays to define our image. First ray is going to go parallel to the axis through the focus. The next one is going to go through the focus parallel to the axis. And the last one is going to go straight through the center of curvature and bounce right back. Okay? So we're going to do the same thing here. I know it said that fast, but we're going to talk it out as we do it. So let's get that first ray. First ray is going to go from the tip of the arrow, just like last time, parallel to the axis, bounce off, and go through the focal point. So once again, we're going to try to draw it more parallel than that last time, but I'm not going to waste a lot of time on that. So hits the mirror, and then we're going to bounce off, and we're going to go back through the axis, and that's going to be ray number 1. So you should have now constructed ray number 1. Again, at any point, since this is a video, you can stop it, rewind it, pause it, do whatever you need to do. You're in complete control of the video. Now, I'm going to break from tradition. I'm not going to go ray 2. I'm going to go to ray 3 right now. Ray 3, if you remember, is the one that goes straight back through the center of curvature without reflecting at any angle. Go straight in, go straight back. So we're going to do that one here. So once again, starting at the tip of the arrow, we're going to line up with the center of curvature, just like last time. Okay, and it's a little bit bizarre. We have to line this up. The ray is going to go to the mirror. It's going to bounce straight back, go through the center of curvature, and not reflect at all. And this is ray number 3. So I'm going to let that sink in for a moment. Okay, cool? And that one, people get weirded out by that one, but it's not that bad. Okay, now we're going to go back to that second ray. Again, it's always the same 3 rays, and how you draw them is always the same. First one was parallel to the axis through the focus. This one was through the center of curvature. Now we have to tackle the one that goes from the tip of the arrow through the focal point, hits the mirror, and goes back parallel to the axis. All right, here we go. All right, tip of the arrow. And we're going to go through the focus. I gotta go here. Okay. You can go through the focus, but you can't draw it. It's impossible. That ray does not exist. That ray would have to go through the object itself, through the focal point, come out of it, and go left. It's physically impossible. So guess what? We're done. That's it. Next question. Are those 2 lines ever going to meet? They are not. This is why we call this geometric optics. These 2 lines, if I draw them right, and they're close, are parallel. Therefore, they're never going to intersect. Therefore, an image is never going to be made. And this would be classified no image. Unlike the last one, there's nothing to measure because there's no image. And hopefully, if I can find the right picture of this, if you stood at the focal point of a concave mirror, you would just see a blobby blur of yourself. You'd still see light, but you wouldn't see an organized image. It would just be a blob. And that's it. So what you owe me is this diagram with all your measurements. There is no image. And that concludes the second video. So thanks. Make sure you get that done.